Good afternoon and welcome back to the Lab Analyse Online Week. The next presentation will be given by Jeroen van Bokstel of Instrument Solutions, and he will be talking about the EasyPREP sample handler. If you have any questions during his presentation or during the live demo that will be given, you can do it on your right-hand side via the chat. And at the end of the presentation, there will be plenty of time to answer all your questions. So Jeroen, I'm handing over to you and you can start your presentation. Good luck.
Okay, thank you, Wendy, for this introduction. On behalf of Instrument Solutions and SAP Science, welcome to this webinar of a presentation and a live demonstration of the EasyPREP sample handler. My name is Jeroen van Bokstel. I'm a product manager for Instrument Solutions. With this presentation, I will briefly introduce the companies Instrument Solutions and SAP Science, followed by an introduction of the EasyPREP sample handler and the possibilities. After that, we will move over to Canada for a live demonstration given by Art Ross. And after that, there will be time for questions and discussions. So, Instrument Solutions is a privately owned Dutch company. We are a supplier of laboratory supplies and equipment. We are active in 3 fields, which are elemental analysis, chromatography, and material characterization. We work with international manufacturers as partners for distribution in the Netherlands or the Benelux. For the Netherlands, we are working with SAP Science as exclusive partners since 2003. SAP Science was founded in 1980 and they are located in Montreal, Canada. They develop and manufacture products to increase laboratory efficiency, and they are mainly active in inorganic chemistry. Their quality is guaranteed by a 3-tier quality system consisting of ISO 9001, ISO 17025, and ISO 17034. The EasyPREP sample handler is part of the EasyPREP platform. EasyPREP platform is our out-of-the-box robotic systems, which are acid and corrosion resistant, which is quite a unique feature, especially for inorganic liquid handling, which the EasyPREP sample handler does. The other systems in the platform are dedicated with chemistry analyzers. You see on the top left is the TiTrack, with this pH and conductivity measurements and pH adjustments. On the bottom, the COD 200 for chemical oxygen demand. The soil analyzer analyzes pH in soil, and the BOD system is an automated system for biological oxygen demand. Okay. So the main capabilities of the EasyPREP sample handler are reagent addition, adding internal standards, normalization by using an ultrasonic level sensor, homogenization by using a bubble stirrer that can do serial dilutions for your standards, do general aliquoting and transferring of inorganic liquids, and also used for any types of dilution of analysis techniques. It's freely programmable, so you can use every rack that you want on the EasyPREP. To give some examples of the applications that it can be used for, I'm using some other products supplied by SAP Science. On the left side, you see the multi-view microwave system, which is a closed vessel acid digestion system, and down below the EasyPREP eating block. EasyPREP can do pre and post digestion assistance for these systems. Before digestion, it can add the concentrated acids and any other reagents. After digestion, it can add internal standard, normalize, then do homogenization with the bubble stirrer, and after that transfer to an autosampler tube, or dilute and transfer to an autosampler tube. Can also be used for all other types of liquid addition and reagent addition, and also can be used for making serial dilutions for standards or making multi-element standards. So before we move to the live demo, I would like to highlight some of the features of the EasyPREP sample handler. Of course, there is the dispensing tube with a bubble stirrer very close by, also the water tube. Next to that, it's the Accu Norm, which is ultrasonic level sensor. So it can detect the exact same level to fill up the volume very precisely. You always need one syringe pump, but there's also an option for a second syringe pump. These can have different sizes and volumes of syringes. There's an HF syringe available, and these both these pumps have a 9-valve port. So this concludes my presentation, and I would like now to give the words to Art Ross from ICP Science in Canada.
Thank you, Aaron. Good afternoon, everyone. It's our pleasure to have this opportunity to present the sample handler in real life. Our product manager, John Azer, is at the helm in Montreal and if you can turn on your video, John, there you go. Now we have the instrument in front of you. So we will do the reagent addition, normalization, aliquoting, and dilution today to show you the capabilities of the EasyPREP sample handler. Before we start, just a few words on what you see in front of you. You see the main instrument, which is an X and Y format that uses stepper motors and timing belts for accuracy of location of vessels. Excuse me. And the Z drive allows us to be able to go down to the vessels. The vessels on the right-hand side you see are microwave vessels. So we have a multi-view vessel and we have an express vessel, and the bubble stirring feature will reach down to the bottom. We'll see this in a little bit. Today's configuration is with the dual pumps, the 25 ml syringes to dispense the liquid. So your acid would be connected to one of the ports. Then we dispense through PFA dispensing tubes. We use either a 0.4 millimeter or a 1.0 millimeter ID for the dispensing tips. Today, when you see blue liquid dispensing, that'll represent nitric acid. If you see yellow liquid being dispensed, that represents hydrochloric acid. The little box to the very left of your screen saying EasyPREP, this is a new feature, which is a bulking pump, so that if you're doing a digestion with 8 mils of acid, after you bring it off of your resistive digestive block, like a DigiPrep block, you would, or you can add a known quantity of diluent and then use the Accu Norm to do the normalization. If you look closely at the Z arm, you see a black device. Maybe we can ask John to bring that to the forefront. If you could bring the Z arm to the forefront, John. So you can see the black device. That is the holder for the level sensor. So we've mapped the level sensor to compensate for any distance differences on the tabletop. So in today's setup, we have the tabletop for a DigiPrep Junior rack, which can also put a auto sampler rack like Jeroen had mentioned for any of the auto samplers that are used on ICP, ICP-MS, as well as the rack that are used for taller vessels for microwave types of digestion vessels. So the AccuNorm allows us to measure the volume in each of the tubes and then dispense the right amount to normalize your sample. So what we'll do is that we will start with reagent addition right now. So John's going to share his screen and we'll see the software and the instrument at the same time, and I'll explain what's happening in real time here. So we'll go to the first step, which is reagent addition. So 1 second and things will come up here. So on the process tab, we've programmed a addition of acids. So we're going to add acids from each of the pumps. So we're not mixing the nitric acid and the hydrochloric in a bottle, then dispensing. We're going to dispense the nitric acid out of one pump and the hydrochloric acid out of the other. So 2 of nitric and 6 of HCl. So John will press the start button and away we go. So on the visualization tab, you can see which vessels are going to have the liquid added to it. So the first step that it's doing is that it picks up the aliquots of the reagents that are going to dispense. Then it will dispense it in the tubes. So you can see that it has dispensed the blue, the nitric, and then the HCl into the tubes. So at the front end, this allows you to weigh your samples into your tubes, bring the rack to the system, pull up a program that can be saved to add the acids to the samples. So you can control how much acid is added to each one of the samples in real time. You can also control the numbering of the rack positions to duplicate your numbering system from, now you see that A1 is in the back left-hand corner. You can make 1 in either one of the 4 corners and count in that direction. So we've added acid to the 4 tubes that are at the fronts for visual effects here. If all of the rack was filled with acid and all of your sample tubes are filled with acid, now you're ready to take it to your block, and you can take it to your block and do a digestion, or stage the next rack to do that so that you can do those things. So John's going to say okay here, and we'll go back to the process page. Just wanted to show you that you can see that it takes about 20 seconds to dispense that 8 mils of acid out of 2 different pumps. And the accuracy in a 25 mil syringe is somewhere about 2 steps, and each step is about 4.6 microliters. So you have excellent accuracy in dispensing from the dispensing pump. So this works very well. It will do a rack of 24 in about 8 minutes. Right, 6 times 1.4, 1 minute and 40 seconds. So once that's all done, then what we can do is that we can now load the next step, because we've finished our digestions, we've brought the rack back. So now it's time to normalize the samples. So John is creating a normalization step. So you plug in the values of normalization that you want to do. So we're going to target volume is 50 ml. Then we're also going to use the bulking pump here. So we're going to add a known quantity of liquid to the bulking pump, with the bulking pump into A18. A18 happens to be just a position that we're doing. So the front 4 positions are A6, A12, A18, and A24. So we're going to do these 3 tubes here. We're going to fill those up. We're going to normalize the first 2 just with AccuNorm. And the theory of using AccuNorm is that it's an unknown volume. So if you put 8 mils of acid into a vessel and did a digestion, we don't know how much has left with precision. But AccuNorm will measure the volume in the tube and then do the calculation to add the remaining solution up to your volume that you would like to normalize. Now you can use any normalization volume that you want. It doesn't matter how much the liquid level is in the tube, it will do the calculation. Some of the assumptions are that all of the tubes are identical. So digitubes are made by injection molding. So we're looking at tubes that are made similarly with a graduation. So you can see that AccuNorm has added the volume to the system, to the tubes. The way that AccuNorm works is that it takes a measurement, does the mathematical calculations, adds 80% of the diluent on the first pass, then remeasures in the center of the tube in the meniscus to do another determination of the amount of liquid required to finish off to the 50 mil mark. That's how AccuNorm works. So color, suspended solids, consistency of the liquid in there is not important with the level sensor. So there we've done the first tube, and we use a color coding scheme here to say green is when it's completed, blue when it's in progress. When you're doing dilutions and aliquoting, we use different colors to control the legend so that when you get used to it, once the system is in your facility, you'll be able to visualize as you walk by the screen to control things. We use a computer with Windows 10 for the control of the system. So this allows you to save your methods. It allows you to pull them up, to manipulate, to configure it to any rack configuration as required. So now we can see that we're doing the second vessel with the addition of AccuNorm. The visualization of the two pumps allows you to see what's happening. The dispensing tips when we're normalizing do not go into the solution, so there's no contamination from sample to sample. It just goes into the top of the tube so that it prevents any splashing out. And typically we're dispensing at 3 mils per second and picking up at a half a mil per second. As you can see, we did that third tube with the bulking pump, and the bulking pump has finished. Now it's dispensing the liquid. And you can see that it's dispensing a small amount of liquid to finish off the AccuNorm. AccuNorm always does 2 steps to ensure accuracy. So a digitube has the accuracy visually of 0.25 milliliters. And with AccuNorm, we can do better than 0.2 milliliters. So visually is 0.25, and with AccuNorm, it's better than 0.2 in terms of completing it. So you can see that we completed the normalization of the 3 vessels. And when we go back to the process page, if we look carefully at the screen, you can see that the first 2 took about 1 minute and 22 seconds to normalize. So remember, that was to go from 8 mils to 50 mils, so to pick up and dispense. And then on the last tube, it took 7 seconds to bulk and then 35 seconds. So to speed up normalization, one could speed normalization up quite quickly within 45 seconds. So almost half the amount of time to do normalization. So now that you've finished normalizing, now you want to do an analysis. And if you have high levels of any one element, you typically want to do a dilution. So now we will set up to do aliquoting and dilution. So we're going to do bubble stirring. we're going to rinse and prime in between. So when you're rinsing and priming, it takes a little more time to do it because we rinse the outside of the probe, we rinse the inside of the probe when we pick up a sample. So when we pick up a sample, we select the pump, we select the port that we want to do. So in our case, we're using our diluent, which is just DI water. So we're going to pick up DI water for the dilution. Then we're going to pick up the sample with the same pump so that we pick up a 1 mil sample from A6, and then we're going to dispense it into A5, and then we will do from A11 to A12. When you have a change of reagents, the pump automatically goes through and cleans out the dispensing line. That dispensing line on the sample handler is a 13 mil dispensing line. So we rinse the inside of the tubes and then we rinse the outside of the tubes. So the tubes, again, are made out of PFA. They're either a 0.4 millimeter ID or a 1 millimeter ID. So we're not worried about the particle size when you're doing a soil sample for aliquoting. So the dispensing tip has gone in. If you look closely at the screen, you can see that we have the bubble stirrer bubbling the sample. Then it's going to pick up the dilution. Then it picks up the aliquot of the sample. This way we ensure that the inside of the tube is rinsed well between samples to prevent contamination by carryover. The speed of dispensing is at 3 milliliters per second, so we have a very good mix. So typically when you're doing a dilution, the speed of dispensing ensures good mixing, so it's not necessary to stir the sample after it's been aliquoted. So we're going to do the reverse here, where we're going to come to the tube here, and we picked up the diluent. Now we're going to go down to the bottom of the digitube. We're going to turn the bubble stirring on to mix the sample. You can see the bubbles in the sample. Then once it's bubble stirring for 7 seconds, we'll then pick up our aliquot of our sample. So with the 25 mil syringe, it's possible to pick up as small as 0.05 milliliters, so 50 microliters accurately to do a dilution. So you can do a 50 microliter to a 10 milliliter dilution quite with good precision, with better than 2% accuracy. So now it's rinsing the outside of the probe. Between samples, we rinse the outside of the probe. And now when it's rinsing the outside, the probe actually moves down into the wash station and then comes back up. So here we're picking up our diluent of 9.75 milliliters, then we'll pick up a 250 microliter or 0.25 milliliter aliquot of the sample after we stir it. And we'll dispense it in the tube behind. And that's how you would do dilutions and aliquoting. One of the other things that you can do with the system is that you can do standard addition of yttrium. If you wanted to do standard addition, you could have a tube set up, and we call this pick and place, so that you can pick and place a particular sample from someplace on the deck and then aliquot it to each of your samples so that you'd have that precision. So this is how aliquoting would be done. So we did reagent addition, we did normalization, and then we did aliquoting and dilutions. So we can have a look at the process here in terms of on the process page of the length of time that it would take to manipulate those kinds of samples. So you can see that depending upon the volume size that you're using, it could be in from about a minute to about 2 minutes to do that. And you can do several dilutions of the same sample if you had to do that. So you could allocate from a sample into another tube. So I believe that we're going to now show you aliquoting from a microwave vessel in terms of a quartz vessel that could be used on a mini wave or a multi-view, or if you have a Nova wave, or an express vessel. Typically, Teflon vessels cannot be normalized. They could be a known quantity could be added to it, and then an aliquot could be taken from it. So John will now manipulate the software here to pull up the next rack set that shows the microwave setup along with the auto sampler rack. So this is a Bellart auto sampler rack. This is for 15 mil auto sampler tubes. So this is a 60 position auto sampler tube. So we're going to work with the microwave vessels. So we're going to add our acids to the microwave vessels. So we're going, typically, one of the nice things of microwave is that you can add just nitric acid to do a digestion of most samples. So we're going to add 10 mils of nitric acid to the Nova wave vessels, to the microwave vessels. In the software on the screen, you see that you can put a break, so you can actually put a pause in between your operations that will require an interface from or an action by pressing any one of the keys. We're good to go, John.
Art, I have a question. Can we see the EasyPREP also on the large screen? So
okay, so
we're looking to a small thumbnail.
Okay, so John, if you could just stop sharing the software, and that way the screen will go bigger, and then you can start the software. There you go. Okay. Thanks, Mark. So we're priming because we moved from one diluent to another. You can see the blue liquid in the syringe. So now we're going to pick up the aliquot of the acid that needs to be dispensed, which was 10 mils. So we're coming to the tube. We're going to pick up the 10 mils of just nitric acid, dispense it into the tube. So we're going to dispense 10 mils into the first tube. Then we're going to dispense 10 mils into the second tube. And if there's anybody out there doing hydrofluoric acid, we do make an all Teflon pump for doing hydrofluoric acid. So there's our dispensing into the tubes. We would then take the tubes, cap them, put them in the microwave, run the digestion sequence, cool the samples, uncap them, put them back on the sample handler, and now we will run the normalization. We're going to use the bulking pump to normalize here. So we're going to just add an aliquot of 40 mils to each tube so that you can add a volume. This is to show you the speed and the mixing capabilities of just dispensing the diluent through the bulking pump. Then once they've been normalized, we can now aliquot. So now we're going to pick up and do dilutions and put it into the auto sampler tubes. So we typically pick up our diluent. Then we come back to the sample. we're going to bubble stir. So we're going to go down to the very bottom of the tube. We're going to turn on bubble stirring so that we have mixing of the sample. And then we will pick up the aliquot and we'll dispense it to a autosampler tube so that you can take it over to your autosampler for analysis. It stays over top of the tube because when we have the bubble stirring, when you turn the bubble stirring off, there is the probability of sample entering that tube. So we turn the air pump on for a split second to ensure that there's no liquid left in that tube. So you can wash in between samples. Wash the outside of the probe, and then we will do a second dilution of the same sample, a smaller one. So you can do dual dilutions out of the tube. Just a reminder that if you have any questions, you can use the chat line on the right-hand side to ask your questions that we will handle here in a few minutes. And there we have our dilutions done. And that is the end of the live presentation. Thank you very much, and I'd like to turn the floor over to Aaron.
Okay, Art. Thank you. And now there's time to ask some questions. Maybe Art, you can stay on with your video end to answer the possible questions of the attendees. Okay, Mark, tell me which kinds of questions you have received.
We did not receive any questions, as you can see in the chat. So let's see.
Come on, people, ask us some questions.
Do you have results from the poll question?
Let's see. 55% says reagent addition, 44% says dilutions, and nobody is doing normalization.
Okay, let me see. I see in the chat two questions. One is from Carlien Gijns. The question is, are there known problems with cross-contaminations for certain elements while performing dilutions? Art, can you please answer this question?
Yes, it's a very good question, and this is all about the control of the amount of washing that one does on the outside of the probe and on the inside of the probe. As a chemist, we typically have learned in our schooling that you need 3 times the volume or you rinse 3 times. So if we pick up 1 ml of sample and we do a 9 ml dilution, we've rinsed the inside of the tube 9 times. So we need to rinse the outside of the probe, and typically we control the depth that the probe goes into, so it's only going in a few millimeters, and normally our default value is that we're using 3 mils to rinse the outside of the probe. So the final answer to the question is we don't see that contamination when we look at the worst case scenario of what's required in terms of the dilution factors that you're using.
Okay, so I have two other questions. The first one is from Regis Nkenda. His question is, what is the exact utility of the bulking pump? Well, the Siemens pump is very precise, but it's relatively slow. So when you do a normalization, you use the bulking pump to first add the biggest part of the volume. The bulking pump is less precise, but it's fast. And then you, with the Siemens pump, you add the last bit to have the good precision for the normalization.
May I add some things to this, Yaron?
Of course.
So the bulking pump uses a membrane pump. It only uses one diluent. It's fine to work with a acid solution to add your, if you wanted to add a 1% nitric acid solution, it's fine to use it with an acidic solution. The bulking pump typically runs at about 13 mils per second. The rule of thumb is that if you add 8 mils of acid to do your digestion on a resistive block, you're going to have less than 8 mils when the digestion is done. So if you're normalizing to 50, you would take 50 milliliters minus 8, and that's the volume that you would add with the bulking pump, and then the normalization can be used to normalize to, with precision, to the 50 milliliters. The precision of the bulking pump is about 1% in terms of the volume that you're asking for. And it's interesting, and having covered the world with sample handler, there are people who do a digestion with the EasyPREP, with the tubes, with caps. Then when they go to normalization, they add a known quantity only as opposed to normalizing it. It's an interesting theory that they're saying they've lost the same amount of acid in the digestion, and they use that non-nominal number as their dilution factor.
Okay, well, we still have 2 more questions. The next one is from Ronnie Michiels. The question is, if you use compressed air from the bubble stirrer from a compressor pump, is that safe for contamination of metals? I think it's a good question, Art. What's your experience with this?
So the pump has no metal parts that's producing the air. It's an onboard small pump, and if you're worried about using a pump and your lab air having contamination in it, you could connect it to an inert gas like argon or nitrogen. You need to provide about 5 bar, and the valve will use that gas as your bubble stirring media.
Okay. Questions keep coming up, so I now have 2 questions from Lira de Vent. Thank you for your questions, Lira. First is a very important one. What is the price indication of the system? It depends on the configuration, but roughly it's between 25 and 35,000 euros. The other question from Lira is, can there be diluted without bubbles, for in case the sample has precipitation, so that you so the intention is to only dilute the supernatant. So then I think you would add the just liquid slowly, and then don't use the bubble stirrer, because the speed is manageable, so you can adjust speed very well. Correct me or add something if you want, Art.
Yes, that's absolutely right. And the assumption is that if you have your sample that has sediment on the bottom, when you go to aliquot it, we make the assumption that it's a homogeneous sample. So if it's considered to be homogeneous, like we showed in the live presentation when we added the liquid to the system, when we looked at that quartz tube for microwave, when we added the liquid, you could see that we had great mixing in it. So we would assume that would be homogeneous. So if your sample is homogeneous, then you can just take your aliquot off of the top and then do your dilution without using the bubble stirring. And bubble stirring is an option that you can add or remove as required for your particular application.
Okay, and in another interpretation of the question could be that if you would have samples that have digested, have cooled, and have settled, that you only would like to take some aliquot from the top to dilute, and because you can manage the height of the probe, you can just take a little bit of the top piece for aliquoting to, for example, autosampler tube. Okay. Final question. Does the equipment need extra specification to handle these assets. For concentrated nitric and concentrated hydrochloric acid, the system can be used as is. It's actually designed for handling these kinds of acids. If you want to handle hydrofluoric acid, then we have to make some adjustments. But in general, it's very corrosion resistant. Okay, so thank you. Thank you for all these questions. Just to share my last slide with you. Of course, it was a general webinar. So for more specific questions or more information, we can test your samples. We have some possibilities for this to do this in the Netherlands. We can help you in method development or do an application-specific webinar for you. Please contact me, product manager of Instrument Solutions. Okay, then I think Wendy will close this webinar on behalf of Instrument Solutions and STB Science. Thank you very much for attending.
Thank you, Jeroen, and also thank you, Art, for the very interesting presentation and demonstration. Very interesting to see. Yes, I would like to conclude with first thanking all viewers for participating in this webinar. And I would like to remind you that we do have some other webinars this week. I will share a link with you, and via this link you can register for other presentations. At 3 o'clock we will have the last webinar of today about reference materials, an entirely different subject, but also very interesting. So thanks again to Jeroen and Art for their presentation, and I'm looking forward to seeing you at another presentation this week. Thank you very much.
Thank you very much, Wendy. Thank you everyone for attending. It was our pleasure to have this opportunity to present EasyPREP Sample Handler. Thank you. Have a great afternoon. Bye now.
Thank you. Bye-bye. Tot ziens.